Hello everyone. Today we're going to talk about how to use reaxys and scifinder. Okay, let's get started. So here's the panel of reaxys. So how you access this website? Just simply type reaxys and then search Google, and you get this web page. Okay, so in this web page, they are pretty simple. That you either search your reaxys or you draw it out. So, for example, when you search reaxys, you can basically search anything you want about chemistry. So, if you want to find a paper on reaxys, you can type in the DOI of this paper. If you want to find a substance of this, if you want to know about this substance, you can also type in the CAS number of the substance, or you can just type in the name of the substance. Or if you want to, sometimes if you want to find some general reactions, you can also type it in. For example, let's yeah, let's just find tech reaction. For example, just to check it out. So now it's we come up with 49,000 of reactions, and then you have 17,000 of documents. So let's just randomly take a look. So if you go inside, you'll find out that these 49,000 reactions, they all have something to do with what I just typed in is a hack reaction. So all these reactions, they are all hack reactions, and then over here, they're also provided um, with the name of the paper, and then you have some not very detailed um, not very detailed condition. Some of the paper they will come up with detailed experimental procedures, such as this one. You come up with a very detailed procedure, copy from the this is a patent. Similarly, you have another patent that has a very detailed protocol how to make this molecule. So from what we can see over here, this is not a very detailed protocol. So if I want to know how to really make this molecule, you can simply just click on here, full text, and then this one will redirect you to the paper itself, and then you can find a reaction from the um, from the paper. And you can from the left panel, you can see over here there are several different things you can try to filter. So first of all, you can filter by the structure. You can draw the structure that you want or you don't want, and you can simply just click limit to or exclude. Similarly, you can have the yield. For example, if I want to choose the reaction only has 95 to 100% yield, I can just click on this one, and then I click limit to this condition. So I'll only see the reaction that has 95% to 100% yield. Or if I say I don't want to see this kind of reaction, I can also just click this one and then click exclude. So the reaction will not show up from 95% to 100%. So the similar things go with the reagent or the solvent. So for example, if you don't want your reaction that use palladium diacetate, you can also simply just click on this one and then you click exclude. So only going to show up the reaction that doesn't contain this reagent. Similar with the solvent, which solvent you want or which solvent you don't want. For um, the rest of the these several filters that I have not used it very commonly because most of the time they are not very useful because they are not very um, accurate. So, but sometimes you can also use this one as a additional filter if you have too many results pop out. Okay, let's go back. Um, so this is just what we search on reaction. What if you have a certain reaction that you want to know, but you don't but you don't know how you cannot just type it in the search bar. It's very simple that you can also draw the reaction out. So if you know how to use ChemDraw, so it should be pretty easy for you to use this one. So on the left, you can create some fonts with this angles, and then you can also make linear more carbon like this, and then you have several for example like a bracket that for polymer. For example, I want to if I see this react if I want to know something like this, I want to know if there's a polymer like this. Okay, okay, that you can also transfer to query to search if there's a compound that looks like this. Okay, let's just go faster to see if there's anything we can find. For example, let's go to a very simple reaction that you start from a benzene, try to make a nitrobenzene. So how to do this reaction? So all you have to do is, for example, if you have any functional group that you want to add that on this one, there are many different types of functional group. You just have to type in the abbreviated group and it will show up, for example, nitrobenzene, but this one is not abbreviated. It's okay. For example, we just type in here nitrobenzene, and we want to know how to make this compound. We simply just put your reactant on the left, and then there's an arrow indicate that this reactant is going to become what you want on this one, which is the product. So sometimes if you want to limit some reagents that you already chosen, you can also type it up, write it up on the top if you can draw. So okay, let's just transfer this one to query and then we find. Oh, but before we do that, we need to review this one and then we find the reaction. Similarly, that we have 98 reactions that reported this reactions directly, and we also have 15,000 reactions that that is something similar to this compound. We'll come back to see this one later, but let's just focus on the first one. Okay, so here are the protocols how to make this type of molecule. Okay, you have you have different types of different protocols. You also have many papers that reported how to make this kind of compound. So as I mentioned before with the hack reaction, you can always type in you can also always click the full text that will redirect you to the paper itself, so you can check the protocol from there. Or some of the paper or patent, they will pop up with this one that is a very detailed protocol on how to make this molecule. And then on the left, as I mentioned, you can also choose your for example, what kind of reagent you want to use, what kind of solvent you want to use. You can limit to or exclude your possibilities over here. Okay, let's go back to the second one. Okay, for this one, that it is a little bit more complicated. So what we only see a 6-member ring benzene, but now with this choice, it's called a average similarity. So that means you can also have some different varieties on the molecules. You have some molecules that look alike, looks like the benzene that we mentioned. That what if you want to run a reaction on that? What kind of what result will you get? Will you get? So here we can see that, for example, this benzoic acid that gets a nitro group on the benzene. So here are all the reactions that have similar to here are all the reactions that that can make this molecule. Okay, second, now you can also see that it's another molecule that's similar to benzene, but it is not benzene. So here are the ways how to make this molecule. So similarly, so here we can see that there are 15,000 reactions that has something to something to do with this. So for example, if I want to say I don't want to see any reactions that contain this that has this kind of molecule or moieties, I can also draw it over here and then limit and then exclude this one. So all your result will not show up molecules that involved in this compound. So similarly, you can also always just type in whatever you can just select whatever different variables that you can choose over here, and then you can try to exclude it or limit it. Okay, so one of the biggest functions of reaxys is actually the synthesis planner. Here there are several plans that there are different several plans for the reaction that I'll just make one example quickly on how to use the synthesis planner. So synthesis planner, that what it do is it helps you do the retro synthesis. So you can know that if you don't know how to make this type of molecule, and then the software will help you try to calculate and search literature to see what kind of molecules, how to see how can you make this type of molecule. Okay, let's build up a molecule real quick to see what we can do over here. Okay, let's say if I want to make this molecule, but I don't know where to start with. So let's put arrow over here. This is your final product. Let's transfer this to queries to see what result we can get. So here that we can see there are several results. So we have substance that we know now we know that this is a substance that is inside this database, and then we also have 45 different other molecules that is similar to the compound that we type in, and then there's zero reactions how to make this molecule, and then there one actual commercial substance that maybe we can buy it from a commercial source. Okay, so let's just go to the first one. Let's see if we can make this molecule. So we can click on this one, create a synthesis plan. Okay, now it's going to show up the synthesis planner. So now it says you find out that there's no reactions that is found to make this molecule. So do we want to use a similar substance instead? So here we can try. Okay, so there are 12 molecules that has the nearest that is looks like the most, and then there are also other there are also other 120 that they are actually medium close to this molecule, and also wild and wildest. Okay, there are actually 709 different molecules that has the wildest range of this to this molecule. Okay, so let's just choose the nearest one. Okay, so here's the reaction that made this molecule. This molecule, of course, again, this is not our design molecule, but you can just use this one as an example. So here we can see that compared to the molecule that we want, the only difference is that over here the fluorine become a bromine, and then we don't have this two. This one also is a bromine over here, and then but this is a molecule that is pretty close to what we have. So here's just a scheme to show that how you make this molecule, and then the resource synthesis of how to do this. Okay, for example, if I want to make this molecule, I don't know how to make this one. I can also create another synthesis plan to make this molecule. But of course, again, this is not the exact molecule that we want. So what you create is to create a pathway of how to make this molecule. For the molecule that is not published, you can only use this one as as a reference, but you cannot you directly apply all this condition and use it. Okay, for example, if you want to see what is the condition to make this one uh, from 3E to 3, compound 3, that we can see that we can see this condition of this molecule. Okay, and then how to prepare compound 3E, that the paper is over here, and then you have the also have the detailed experimental procedure over here. And if I want to see how to make compound 3, I can also I can also click this one and then show the condition. So it's going to show me how to make this compound 3 over here. It also has a detailed protocol over here until you figure out a way to make the final product. But again, this is not the compound that you type inside. This is only the compound that is similar to your molecule. For even more complex molecule, maybe this synthesis planner is not going to be too much useful. Okay, so here's roughly the tutorial about reaxys. So right now, let's go ahead and take a look on the scifinder. Scifinder is similar to reaxys, but if you wanna use either one of them, I would suggest you to use reaxys, as you don't really have to register this website. You can always just open the website and then you start using it. But if you want to use scifinder, you need to first register an account for that. But it's okay. It's actually free of charge. But feel free to try it on your own. Okay, so similar to reaxys, there are also several different search bars over here. So for example, if you want to search for all types of answers that you can search keyword, you can search what we type, like substance name, or you want to type a kind of reaction name. You can also try to check the CAS number or a patent number, this or a like paper a DOI link. You can search everything. Or if you want to search a substance, you want to find a substance, it's also very similar. For example, if I want to find what we mentioned before, the p-nitrobenzene. Here we can. Okay, let's just draw it out by ourselves, so we can. Oh, so here. Okay. Okay, so you draw our benzene, and then you use an arrow indicate that this reactant become the product. So what is your product? That's so let's do it this way. Okay, and then this goes to your product, which is nitrobenzene over here. Okay, so we type OK. But actually, what we are actually doing is we didn't type. We should only type substance over here. But let's see if we can help us, get any result. Okay, so there are 6 reference. There are actually more than 6, or actually 9 substances that has contain this structure. Okay, so this is okay. So if you click inside that, it gives you different different paper inside. And then if we go back, and then this time let's just draw a substance. Okay, instead of drawing out the reaction. Maybe easier to see this way. Okay, for example, if I want to find out this substance, is it commercially available? Okay, let's draw out lactose pentaacetate. Let's take a look. Okay. Oh, so this is the part that that is different from reaxys because you cannot just type in the abbreviation of your functional group, that you have to draw it out directly. Or if you can find a shortcut over here, that you can also use this kind of shortcut. But if not, you have to you might have to just draw the full structure. Just none of this can actually help you do that. Okay, let's just draw the structure directly. So see, this is the difference between scifinder and reaxys. In reaxys, you can directly use the you can directly use the you can in reaxys you can directly just click in the just type the abbreviation of this compound, and then you can find what you want. But here it seems like you need to draw everything. Okay, for some reason it doesn't let me draw. Okay, let's just do it again. Let's just let's just draw the okay, let's just draw this substance out. Okay, and then we search it. Okay, so currently that okay, so here that we show if we want to find this substance, that there are actually many different results, but they are mostly just showing the same compound. There's actually some difference. When you search this substance, it doesn't tell the sign finder about the bond, the orientation of the bond. So it gives not only the compound I want, which is galactose pentacetate. It also shows up as glucose or of, of mannose, but which they have actually different structure than this one. But it doesn't really recognize the 3D structure. But let's just ignore that for now. We can go to the supplier. You can see that where we can buy it, and then we can go back and then see how to make this type of compound with the reaction. Okay, how to make this compound. There are some paper, and then there are some experimental protocol that shows up. Okay, yeah, this the detailed protocol over here, and then we can also try to find the reference in what paper that they discuss about this type of molecule. Okay, you can find it all over here. So for the reaction, it's also very similar. Just draw, for example, what I mentioned before. You have a benzene, and then you want to make a p-nitrobenzene, and then you have a p-nitrobenzene over here that you want to search how to make it. Okay, so similarly, that you can find out. Oh, if your starting material, your benzene is commercially available, or if your compound, your desired product is commercially available. And then you can also find out what I said over here, that you can find out the reagent, and then you can find out the reaction details, how to make this compound. But it doesn't really for some of the reactions, doesn't really give you the detailed protocol of how to make it. But but similarly, you can always go back to the paper and try to find it inside. Okay. For the reactions, there's also one more feature. Say, as you mentioned a couple seconds ago. Let's find out that molecule again. Let's see, draw it out over here. For example, if I have this molecule, and then I have this. Let's create a, oh, see, the retrosynthesis is not available for this structure. So it has to be certain structure that, okay, so apparently this retrosynthesis is also not very useful. Doesn't really gives you, when you type in a complex molecule, it doesn't really gives you any result. But again, this is basically how we use scifinder. And then also there, if you want to try to find some reference and suppliers, you can also type it over here. But as you can see, you can just type in the substance, and then you can also find supplier inside the substance. So this scifinder, you don't have to choose it over here. You can just randomly start from ore or substance, or if you want reactions, and then you can directly get the information about reference and suppliers. Okay, I think that's it for our tutorial of scifinder and reaxys today, because we mainly focus on organic chemistry. For scifinder and reaxys, one of the limitation of these two software, these two websites, it's they have done a good job on the organic chemistry, but for some type of inorganic compounds or inorganic reactions, it doesn't really gives very detailed reaction or how to make this. As a matter of fact, when the compound has a 3D structure, it's generally very hard to draw on the chem draw. So that's why if you want to draw it out on the similar panel like a chem draw, you can it's sometimes very hard to do that. So therefore, to find the reaction about organic molecules, they are generally harder to do. Sometimes we can only just type in the query over here to find something similar, and then you start from that to find what you want. All right, thank you very much. Thank you very much. Have a good day.